Dear children, now we are going to discuss the third lesson, a pair of linear equations in two variables. We have already discussed some parts of this lesson. Now let us revise it first. What are the general forms of a pair of linear equations in two variables? a1x plus b1y plus c1 equal to 0, a2x plus b2y plus c2 equal to 0. We have already discussed these equations equal to 0. Now these are the a pair of linear equations in two variables x and y. When we treat this equation alone, it is a linear equation in two variables. Linear means the exponent or power of variables, each is 1. So this is a linear equation in two variables x and y. How many solutions are for such a linear equation in two variables? We have infinitely many solutions for a linear equation in two variables. For example, consider this: 2x plus 3y equal to 5. This is a linear equation in two variables. What are the solutions of this? How will you find the solutions? X and y. If x equal to 0, what is y? X equal to 0, 2 into 0, 0. 3y equal to 5, y equal to 5 by 3. Y equal to 0, 3y, 3 into y, 3 into 0, 0, 2x equal to 5, x equal to 5 by 2. Then if x equal to 1, what will be the value of y? 2 into 1, 2, plus 3y equal to 5, 5 minus 2 equal to 3, 3y equal to 1. If x equal to 2, then 2 into 2, 4. 4. 3y equal to 5 minus 4. Y equal to 1 by 3. In this way, for any value of x, or when we replace x by any number, we get a corresponding y. Thus, we have seen that a linear equation in two variables has infinitely many solutions. But when we consider a pair of linear equations in two variables, let us see how many solutions are there for such equations. First is, as we have already seen, a linear equation to a pair of linear equations in two variables has graphical solutions. One, the graph of these two equations. We know that what is the graph of a linear equation in two variables? It is a straight line. So this represents a straight line. This second equation also represents a straight line. So the graph of these type, a pair of linear equations, there are three possibilities. One, the graph can be intersecting lines. Here, equation 1. Let this be the graph of a1x plus b1y plus c1 equal to 0. This is a2x plus b2y plus c2 equal to 0. They intersect at a point. Intersecting lines. Second possibility, parallel lines. The graph may be parallel lines. Let this will be the graph of the equation a1x plus b1y plus c1 equal to 0, a2x plus b2y plus c2 equal to 0. Third possibility. Third possibility is coinciding lines. Coinciding. That is, same line represents both the equations. A1x plus b1y plus c1 equal to 0. A2x plus b2y plus c2 equal to 0. Same line. Here parallel lines. Parallel lines. Parallel lines. Here coinciding lines. The graph of a pair of linear equations may be either intersecting lines or parallel lines or coinciding lines. When the graph of a pair of linear equations in two variables is intersecting lines, then they have a common point, intersecting point, or a point in common, and this has two values, x, y, two values. That means x has a unique value, y has also a unique value. That means intersecting lines have a unique solution. Have a unique solution. On one and only one solution. Unique solution. Intersecting lines have a unique solution or one solution. But when the graphs of this equation are parallel lines, is there any common point for both of the lines? There is no common point for both of the lines. That means these two lines have no common point. Implies they have no solution. No solution. For parallel lines, no solution. No solution because they have no common point. So, such equations. Now, the third case is coinciding lines. That is, one line, second line is also on the first line. That is, a single line stands for the graph of the first equation as well as the graph of the second equation. That is, we say that the graphs of certain types of pair of linear equations in two variables are of the form coinciding lines. Then how many solutions are there? Do they have only a single common point or no common point or many common points? Yes. The coinciding lines have many common points. All the points. In other words, all the points are common. So how many solutions are for such equations? Many, infinitely many solutions. Now from these graphs, it is clear that a pair of linear equations in two variables has graph either intersecting lines or parallel lines or coinciding lines. If the graphs are intersecting lines, then it has they have a unique solution. X has a unique value, Y has also a unique value. And if they are parallel, there is no solution. And if the coinciding lines are there, many solutions are there. Now, the equations satisfying this condition, that is, if the graph of a pair of linear equation is intersecting lines, graph is intersecting lines, then such equations are called consistent equations. Consistent equations. So, for consistent equations, we have intersecting lines as graph and has a unique, for these equations have a unique solution. And if the lines are parallel, for any pair of linear equations, the lines are parallel, then there is no solution. Such equations are called inconsistent equations. Inconsistent equations. So inconsistent equations, graphs are parallel lines and have no solution. No solution. Now the third pair, coinciding lines, graphs of coinciding lines. These have many solutions. Such equations, the equations having the graph of coinciding lines are called dependent equations. Dependent equations. Remember that since they have many solutions, infinitely many solutions, they are also consistent. Consistent dependent. They are also consistent. Consistent dependent. So we can summarize this. We can summarize the same in this manner. Equations a1x plus b1y plus c1 equal to 0. a2x plus b2y plus c2 equal to 0. If the graphs are intersecting lines, then name of number of solutions one solution or unique solution. Name of the equations. Consistent. If the graphs parallel lines, no solution. Number of solutions, no. Inconsistent equations. If coinciding lines, many solutions, consistent dependent equations. Now consider the equations. 2x plus 3y equal to 5 and x plus 3y, x plus y equal to 2. Consider these two equations. 2x plus 3y equal to 5, x plus y equal to 2. How can we draw the graph of this equation? Put the x for the first equation, give a value for x. X equal to for x. The easiest way of finding the coordinates for drawing the graph of this equation is this. Put x equal to 0. Then what is y? X equal to 0. We get y equal to 5 by 3. Then we get a fraction. If we get a fraction, it is difficult to mark it in the Cartesian plane. So instead to get a natural number, let us take x equal to 1 in the equation. Then what is y? 2 into 1, 2. 5 minus 2, 3. 3y equal to 3, 1. So 1, 1. Here, x. Then we, this is 5. X equal to 2. Let x equal to 2. Then we get 1 by 3. Y equal to 1 by 3. X equal to minus 1. X equal to minus 1. Then 7 by 3. That is also difficult. X y equal to 0. Y equal to 0. Let y equal to 0. Then we get x equal to 5 by 2. 5 by 2 means 2.5. So we can plot this point in a graph. Here, one, 2, 3, 2.5, 1, 2, 1, 1. Well, 0, 2.5, y 0, x 2.5. This is a graph of the equation 2x plus 3y equal to 5. 2x plus 3y equal to 5. Then consider the second equation. Second equation, x plus y equal to 2. X, y. If x equal to 0, then y equal to 2. If y equal to 0, x equal to 2. Then x 0, y equal to 2. X 2, y 0. X 2, y 0. X 2, y 0. 1, 1. This is the graph of the equation x plus y equal to 2. Then we get the graph is an intersecting line whose solution is 1, 1. The graph of these two equations intersecting line, this intersecting line, and have a unique solution. Now let us consider another pair of equations. 2x plus 3y equal to 5. 2x plus 3y equal to 8. 2x plus 3y equal to 8. Now, let us draw the graph of these equations. For example, first one, x equal to 1, 2x, x, the first equation. As we have already seen, take x equal to 1, then we get a corresponding y equal to 1. And when y equal to 0, x equal to 2.5. Then plot these points. 1, 1, 1, 1. This is the point. 1, 1. X coordinate 1, y coordinate 1. X coordinate 2.5, y coordinate 0. 2.5. Then graph. This is the graph of the 2x plus 3y equal to 5. 2x plus 3y equal to 5. Straight line. Then second, to draw the graph of the second equation, take y equal to 0, x, y equal to 0. Then 2x equal to 8, x equal to 4, x equal to 4. Then take y equal to 1, y equal to 1. Then 3 into 1, 3. 8 minus 3, 5. 2x equal to 5, x equal to 2.5. X 4. So extend this way. 1 unit. One more unit is required. Then x 2.5, y0, x4, y0, x4, y1 2.5, y1 2.5, 2.5, 2.5. Mark the first coordinate x4, y0. This is the point. Second point y1, x2.5, x2.5. This is x2.5, y coordinate 1. Now let us draw the graph. Draw the graph. This is the graph of the equation 2x plus 3y equal to 8. Now look at the graph. Do they have any common point? No. They are straight lines. So this is in the form of second. There is no solution. So these equations, the graph of these equations, a pair of straight lines. Now, second, third, consider third pair of equations in this manner. 2x plus 3y equal to 5. 2x plus 3y equal to 5. 4x plus 6y equal to 10. These two equations. What are the coordinates of these two equations? We can find it to draw the graph. X, y in the first equation. X equal to 1, y equal to 1. X equal to, y equal to 0, x equal to 2.5. Now second equation. Same, x equal to 1. Then what is y? X, y. X equal to 1. 4 into 1, 4, 10 minus 4, 6, 6 by 6, y equal to 1. Is y equal to 0, 4x equal to 10, x equal to 10 by 4, 2.5. See the same coordinates. X 1, y 1, x 2.5, y 0. Here also x 1, y 1, y 1, x 2.5 by 0. Then what will be the graph? The graph will be, suppose this is the 1, 2, 2.5, 1, 2, 3. Let this be 2.5 and 1, this. These are the points. Then if we draw the graph, see this is the graph of first equation 2x plus 3y equal to 5. What is the graph of second equation? Same line coinciding 4x plus 6y equal to 10. So this is in the this equation satisfy the third condition, that is their graphs are coinciding lines. So now let us compare this. The graphs of a pair of linear equations of this form have either intersecting lines graph or parallel lines or coinciding lines. Like this. Coinciding lines. Now let us see the features of the equations which give us intersecting lines, parallel lines or coinciding lines. Let us compare the coefficients of the equations in first set. What are the coefficients? A1 by A2. Here in this case, A1 by A2 equal to 2 by 1. 2 by 1. What is B1 by B2? B1 by B2, 3 by 1. C1 by C2, 5 by 2. Is there any relation between A1 by A2 and B1 by B2? They are different. A1 by A2 equal to 2 by 1, 2. B1 by B2, 3 by 1, 3. That means, in this case, where the graph is intersecting lines, in this case, A1 by A2 is not equal to B1 by B2. A1 by A2 is not. That is ratio of the coefficients of coefficients of the first equation and the second equation. A1 by A2 is not equal to B1 by B2. Now let us find the same ratio second set. A1 by A2 for parallel lines. a1 by a2 equal to 2 by 2 equal to 1. What is b1 by b2? 3 by 3 equal to 1. What is c1 by c2? 5 by 8 not equal to 1, different. So in the second case, where the graphs are parallel lines, a1 by a2 equal to b1 by b2. Here a1 by a2 equal to b1 by b2, but not equal to c1 by c2. c1 by c2 is equal to 5 by 8, not equal to c1 by c2. Now third case, what is a1 by a2 for coinciding lines? a1 by a2 equal to 2 by 4 equal to 1 by 2. b1 by b2 3 by 6 equal to 1 by 2. c1 by c2 equal to 5 by 10 equal to 1 by 2. That means, what is the relation among the coefficients? That is a1 by a2 equal to b1 by b2 equal to c1 by c2. Then coinciding lines, many solutions. Now we can rewrite this once again. According to the property, equations, graph, nature of ratio of coefficients, number of solutions, name of equations general form a1x plus b1y plus c1 equal to 0, a2x plus b2y plus c2 equal to 0. Graph intersecting lines. Ratio of coefficients a1 by a2 not equal to b1 by b2. Nature of the ratio of coefficients. a1 by a2 is not equal to b1 by b2. Then how many solutions? Unique, one solution. Or one and only one. One solution. That is a number for x and a number for y which satisfy these two equations. Name of the equations: consistent equations. Second, parallel lines. Graph of parallel lines. Nature of the ratio of the coefficients a1 by a2 equal to b1 by b2 but not equal to c1 by c2. Ratio of the constants are not equal to ratio of the coefficients of the variables. Solution: no solution. Name of the equations: inconsistent equations. Inconsistent equations. Now, third, coinciding lines. What is the nature of the ratio of coefficients? a1 by a2 equal to b1 by b2 equal to c1 by c2. How many solutions? Infinitely many solutions. Name: dependent, consistent. Here the ratio of the coefficients a1 by a2 and b1 by b2 and c1 by c2 are equal. So we can frame the equation. The last example: 2x plus 3y equal to 5, x plus y equal to 2. Here a1 by a2 is not equal to b1 by b2. Then 2x plus 3y, it is better. 2x plus 3y equal to 5. Then 2x plus 3y equal to 8. Here coefficients of x, coefficients of y are same. Here 2 by 2, 3 by 3. They are equal. A1 by A2, B1 by B2. But C1 by C2, only the difference is constant terms. Constant terms are different. Now third set, 2x plus 3y equal to 8. Then 4x plus 6y equal to 10. 2 by 4, that is the first. Actually, in the dependent equation, case of dependent equations, the second equation is equivalent to the first, or we can write the second equation from the first by multiplying a same number to the coefficients and constant term, or we can get the first equation from the second by dividing the same number throughout the equation. So one depends on the other, or the second equation is derived from the first, or the first is can be derived from the second. Such equations are dependent equations. Dependent equations are also consistent, so they have many solutions. Now, read the textbook pages 38 to 49. Study the examples 1 to 6. Also do the exercise 3.1 and 3.2. Thank you.